As of now, we spoke about two types of angular quantities that we said we can use to describe the way objects experience angular or rotational motion. So we spoke about angular velocity given by the Greek symbol omega, as well as angular acceleration given by the Greek symbol alpha. Now, as of now, we saw that there exist formulas that we can use to calculate the magnitude of these two angular quantities. Now, even though angular velocity and angular acceleration are not exactly true vectors, we can treat them as vectors in the sense that these two angular quantities not only have magnitude, but they also have direction. So how exactly do we find the direction in which angular velocity and angular acceleration points? Well, let's look at the following two diagrams. In diagram 1, we have the following circular disc that is rotating in the counterclockwise direction about an axis of rotation. So this is our axis of rotation, and our object is rotating in the following direction. Now, what about the second diagram? Well, we have the same exact object, but now the disc is rotating in the clockwise direction. So it's rotating this way. In order to find the direction of angular velocity, we have to apply the right-hand rule for angular velocity. So the right-hand rule states the following. You take your right hand and you curl the fingers in direction of rotation around the axis of rotation. So I take my hand, so we're doing this case here. I take my hand and I rotate my fingers in the same direction as my rotating disc, so I rotate counterclockwise. Next, I extend my thumb, and my thumb points in the direction of angular velocity omega. So in this case, I extend my hand around my axis of rotation. It rotates in the counterclockwise direction. I extend my thumb, and my thumb points upward. So that means when the object is rotating counterclockwise, my angular velocity will point upward. Now, if I look at this condition, now I have to extend my hands clockwise, and now when I extend my thumb, it points downward. So in condition number 2, in situation number 2, our omega, angular velocity, points downward. Now, what about angular acceleration, our alpha? Well, let's look at the following table. Let's suppose our object, circular disc, is rotating counterclockwise. Now, if our angular velocity is increasing, that means our acceleration, our angular acceleration, will point in the same direction as our angular velocity. So it will point upward. Now, what about if it's decreasing? Well, if the angular velocity is decreasing, that means our angular acceleration will point downward in the opposite direction as our angular velocity. Now, if we look at the clockwise case, if our disc is rotating clockwise and our omega, our angular velocity, is increasing, then that means our alpha, our angular acceleration, will point downward. And if our omega, our angular velocity, is decreasing, that means our alpha, our angular acceleration, will point upward.